All right. Hello, everyone. My name is Dan Burke. Forgive me, I've run through this rehearsal many times, and I'm always at exactly the 25 minutes, so I'm going to be speaking very rapidly, and I may not have time for questions at the end. I'm not speaking rapidly because I'm out of or nervous, but because of time constraints. So what we're here to discuss is alternate realities in collaborations. What I'm talking about is virtual reality, augmented reality, and mixed reality. And as it relates to not just telepresence or holoportation or stuff like this, but also even tech engineers out in the field at Cisco sites. So, a little about myself. I hate self-promotion, but here we go. It's obligatory. I've been at Cisco for about 13 years. I've been involved in virtual reality, augmented reality for since about 2013, doing stuff mostly at home and over weekends. But then my manager became aware of that and brought me to Cisco Live and showed demo stuff at almost every Cisco Live ever since then. IEEE demos, Ignite US, stuff like that. And if I have time, I'll be able to show you some of the work I've done in that regard. I'm also a member of EVAR, which is Enterprise Virtual and Augmented Reality. It's a Cisco, just a group of nerds that got together to build some VR, AR stuff that won last year Cisco's first Innovate Everywhere Challenge. I also won the first ever Microsoft HoloLens hackathon last year, and I've become Unity certified as of last year. Okay, sorry about that. Now we're done. Okay, so part of EVAR, one of our demos that we gave at Cisco Live and GSX last year, was all about the remote expert. This is where you don a HoloLens headset, and I'm not going to go into any of the optics that are available today. The service that we're offering is able to handle anything and any game engine that you want to throw at it. So keep that in mind. We're not targeting Unity game engine or Unreal or anything like that. We're allowing all game engines to play nicely with our backend service. And any optics as well, HoloLens down to the Google Cardboard, what have you. So here, the experience is that a tech engineer, let's say, goes to the Cisco customer site and he puts on a HoloLens and he looks around the data center and he sees a Cisco switch. That's what you see on the table over here. And the HoloLens will recognize it for what it is and replace the 3D mesh of what it has scanned with a 3D model accurate of that same hardware. And so it has the internals. This is just a simple Cisco switch, but you can imagine the multi-chassis systems, the CRS 1000s that have, many line cards that are configurable by the customer. So to be able to bring in that model accuracy into the remote site is priceless. Then he is able to instantiate or invoke a remote expert. So somewhere at Cisco campus, a remote expert will be wearing a HTC Vive virtual reality headset, and in his vision, he is able to see the Cisco switch or Cisco hardware that you're looking at. And he is able to, with the Vive controllers or hands or whatever, it's millimeter accurate, so he can go into the Ethernet ports and point to the power supply unit he wants the customer to unplug, stuff like that. And in the real world environment with the HoloLens, you'll see the hologram of that avatar manifest itself right in front of the switch. This is video taken through the HoloLens. You also see, so he's demonstrating how to remove the power supply unit, so I'm following his instructions. You also see a 3D cutout, like a portal, showing you the inside of the hardware. That's where the multi-chassis system that's perhaps experiencing some back pressure on a line card can actually cause an alert and cause it to glow red as an X-ray vision, so you know exactly where to go. Let's talk IoT. So in my living room, I have a Raspberry Pi running an MQTT broker, an IoT gateway, and I have IoT devices like this little chip. All it's doing is it's a very fast-running UDP listener that's listening for packets describing a volume that I then use to display inside of this volumetric display. That volumetric display, let me pause the video and rewind. Oh shoot, I don't have rewind controls. Okay, so keep in mind that the IoT device has no spatial awareness. It's just listening for UDP packets and will light the LEDs that you tell it to. But because I'm observing the scene using this I keep pointing to my screen here, and I don't have a laser pointer, but the tablet I'm holding is a Tango tablet. It has 3D depth sensors, so it's built a 3D mesh of the environment it's observing and is able to recognize the IoT device sitting on the table. So then it has the spatial awareness. The IoT device is still dumb, but because the camera knows its relative position to it, if you imagine a lightsaber beam coming out from the back of that Tango tablet, it knows precisely which pixels in that 3D volumetric displays that lightsaber would intersect. So this, of course, makes no sense in a real, in our realm, but if you can imagine a smoke alarm that, like an IoT-based smoke alarm that is intelligent enough to understand the nearby fire escapes, or digital ceilings, Cisco's digital ceilings, you can start to do pretty clever behaviors. This is a more recent demo that we have running inside of San Francisco eMERGE group. So, ignore the fact that it's Star Wars based, it's lightsabers and helmets and droids and all that stuff. Picture instead PowerPoint presentations or 3D objects of things that you wish to share with colleagues, and you get a sense of the type of stuff that you can do. The important takeaway about this is that you're actually sharing real-world coordinates across disparate devices. So you have 2 HoloLenses in this room, an HTC Vive, there's a Tango tablet, a WebGL renderer just running on a laptop. All of these are actually, they're aware of one another's relative location. So you can have a lightsaber duel like this. This is actually Dylan Fox sitting right there. He's wearing the other HoloLens, and I superimposed a Darth Vader helmet on top of his head. And the interesting aspect of this is that the spatially aware devices, the head-mounted displays such as the HoloLens, are the ones that are communicating their location rotation back to our backend service and then broadcasts to all interested devices. And I have a little bit, this is from the view of the HoloLens. And you see a lightsaber, a Stormtrooper helmet attached to the HTC Vive headset. This is David Reekman, also from the eMERGE team. He's holding the Tango tablet, and you can see that I'm anchoring a training droid from Star Wars to that device. Now, for real live demos, knock on wood. I should have had this running before. Oh yeah, the Connect camera is picking me up and I shouldn't be there. Oh shoot, it's not sharing my screen. How do I share my screen here? Sorry, does anybody understand? How does one do that? Just hit escape. Thanks very much. So forget the yoga posing inverse kinematic doofus over here, but so let me step out of the camera's vision and show you instead. So this is a Tango tablet, and this is controlling the location of this training droid, and as I walk around and scan a 3D mesh, you can see that it's actually building a real-world 3D mesh of what it's sensing. And that mesh is being communicated not just back to this laptop, but to the central server that is then deploying that to anybody observing this room. So imagine in a boardroom setting, whenever anybody enters that realm with a 3D capable device, I'll even do the ceiling so you can see, or maybe behind me. It's the last person to enter the room with a 3D sensor will effectively just replenish that 3D mesh and keep contributing to it and keep updating it. Yeah. So anyway, that's one of them. And I'll jump right into the second one. If I can get rid of this. And it will require that I restart. So I have had very little time to test this setup here, so let me, great. What I'm doing is I'm controlling an avatar's, are you still able to see me? Let me unfortunately, I'm not going to be able to maximize the screen this time. And let me bring up the room. Sorry, I'm wasting valuable time here. You can see that it is tracking my joints, and it is forward kinematic controlling this remote avatar. So this remote avatar is effectively what you'd see on the headsets. By the way, the reason the legs are doing that funkiness, the Kinect camera it has a confidence rating for every joint that it's measuring on my body, and because it's aiming, you can see the video that it's only seeing my waist. It has no knowledge of my legs, so that's why it's kind of guessing. Yeah. Come on. All right. So, just controlling an avatar like this, however, is not important enough. Is not impressive enough. What we want to do is to be able to paste the person's face onto that avatar in an accurate way. And this, of course, is a 2D camera grab, regardless of the position of the person. So even if I move sideways, it's still going to track my head onto a 3D avatar, which is not ideal. Instead, what you want to have is a mesh like this that is actually able to It tracks not only my head rotation movement. Actually, I went too far there, but you get the idea. And because it's entirely recreated, yeah, the legs are coming back up. Because it's entirely created inside of VR, in VR, we can completely control the lighting as well. So it is an actual 3D object being serialized back to the back end and deployed to all observing devices. I don't know if I want to risk doing this. What the heck? No, I can't do that. Yeah, anyway, I'm sure you've seen, what the heck? I'll try it. I'm sure you've seen this before, the standard 3D depth maps being displaced by, come on, where is it? I think I pushed the demo gods a little too far there. I can't seem to pull back. Come on. No, I'm completely lost here. I'm not sure where I am. Okay, well anyway, this 3D mesh is a full 3D scan. Unfortunately, the bandwidth it takes to serialize that entire UV map, depth map, back to the server and back down to the clients so far is proving too high, and so the latency is terrible. The best I've seen is about 15 frames per second, but there are other companies that are actively working on improving that. So anyway, yeah, sorry, that was a bad idea. And to talk about the back-end service I've kept talking about, if you are familiar with the Unity game engine, hello? The Unity game engine, which is what's powering most of these demos, it's great, and why wouldn't I have built all of this on top of just Unity networking component? Well, it's good, but it doesn't offer persistence. That's one of the big caveats to Unity networking. And of course, it's not compatible, cross-compatible with other game engines. So if you have another client built in Unreal, sorry, you can communicate that way, but you'd have to be proprietary. Anyway, I know I'm running out of time, aren't I, already? So what we've built is something called Archer. We're calling Archer. It's the Augmented Reality Content Repository. It's based on very well-proven 2 open source projects from Apache called Sling and Jackrabbit. And it's based on an OSGI platform. So it's infinitely scalable, very modular. Modular meaning that even just the authentication authorization aspect can be entirely replaced with Cisco-specific, let's say the OAuth 2 mechanism from the Spark APIs. The storage, by default, I think it's NoSQL, can be replaced with MongoDB, whatever you want, and can be deployed. We take care of all the endianness, the byte endianness, so you can deploy on Mac, Windows, Linux, either as a standalone application, the host itself, or in a Docker container and have it managed by Kerberos. And the core content of this repository is node addressable. It's a massive directed graph. So consider like this hierarchy depicting the entire universe. So you can have North America broken down by state, city, building, floor, room, corner of room, table, like you can go down to infinitely small as well, and there's no limit as to how much you want to separate those levels. The benefit of doing that is that every node addressable, every addressable node is then observable. When you go into a given realm, let's say a boardroom with a HoloLens, and you say, okay, I've entered this room, and the glasses will automatically recognize the room for you. It's not something you have to tell the glasses. Then it will start observing anything else moving within that room. So anybody that has another head mount display or is manipulating 3D content on the web browser or anything like that will manifest itself in your vision because you're observing that. And so it's quite powerful in that respect. Very secure. Cascading access controls. Sorry, I'm just going to blow through these a little bit. Everything is okay, so that's one quite important aspect as well. There we go. Right now we have prototypes of almost every device we could get our hands on, including something that isn't listed here called Cast AR. We've done Cardboard, Tango, Vive, Oculus, HoloLens, blah, blah, blah. The list goes on. And we're future-proof, so when finally the Magic Leap comes out, we anticipate being able to control that no problem because it doesn't rely on Unity. But you can communicate from the device, or let's say even a Python script running on a network operating system inside of a Cisco hardware, can communicate to the back end using many different protocols. REST APIs, of course, being probably the preferred one, RMIs, WebDAV, WebSockets, or custom proprietary stuff, again, because it's modular OSGI. The formats can, again, be entirely proprietary. We host a number of different ones by default. And that, I believe, is it in a nutshell. Have I gone over time? If not, I can either take questions or show you a couple more demos. Your call. Demos? Questions? Demos? Okay. So these will just be pre-recorded. Is that okay? Okay. So this is one of the ones we had at Cisco Live since about 2013. So the group I worked on before was called Viral, Virtual Internet Routing Labs. We were able to take an actual Cisco network, virtualize it on OpenStack. So it's actually running the real network operating systems of actual Cisco hardware. And then I had the clever idea of why don't I take that and bring it into virtual reality. So I can actually virtualize the network, bring it into virtual reality. So you get kind of two levels of inception there. Bless you. So we had about 1,000 people run through this demo at every one of those events, and they put on a headset and they can perform. Right now, you're doing a trace route, sorry, and it's pulling you along, inducing motion sickness. So brings you up to the ceiling. You can see your entire network, and okay, good. And you can actually change the visualization layers being rendered on the ground from your OSPF to IBGP, EBGP, all that, MPLS, all that stuff. And as you walk up, I think you may not have seen that. I wish I had a way to rewind this. I think I might do it again right now. Yes, right here. So as I walk up to any one of those big Cisco boxes, as I touch it, the console appears above me, so I can actually make network configuration changes in virtual reality, and because it's virtualized, it actually has the effect, and the LEDs will act accordingly. So if I go to the back of the box, unplug an Ethernet cable, all that stuff. And because it's communicating to that same back end, you can render that same floor plan on any HTML5 compatible device. So we just have a small mobile device rendering it in a 2D format. And these little, I'm pointing on the screen here, but the green and purple cones moving around are the viewpoint of each Oculus Rift, and it's collaborating on the same space. Do I have a way? There we go. And lastly, this was the HoloLens hackathon in San Francisco. So it did it's pretty much the same as I showed you with the Tango right here. It is doing a 3D scan of the entire room, shrinks it down to the tabletop, and notice that white cube right there? That cube is representing the location and position rotation of my colleague's head. That's my colleague with another HoloLens on her head, and as she's walking around, I can keep track of her as she moves through the building. So consider this in a multi-site deployment. So when you are speaking with colleagues, let's say a cast AR system that doesn't have the funky glasses, you just have a tabletop here, and you can instantiate your remote colleague's workspace right on the desktop here and see where they are. Oh, no, you've gone down the wrong alleyway. I want you to turn back. Yeah, that's right. And you can actually direct them in that respect. I think that may be it. I'm amazed that I got through it all. Yeah, and then I'm into the backups. So I do have, no, I don't have time for questions. Maybe 30 seconds if anybody wants. Oh, shoot. I don't have time to do this, do I? Okay, so last thing I'll quickly mention is in the holoportation demo with the Kinect camera that showed you that funky looking avatar, very robotic, but with a human face. If I go to the back end, to the server right here, and you can see this is what I meant by it's right now separated by geography. So, there we go. So the augmented reality realms here, you see San Francisco, Norway, Gaul, Storefjell, Lamar City, this is this room, and this is my funky looking body. The avatar that's currently assigned to it, oh, this hasn't refreshed, sorry. If I had, you would have seen that it would have been robot. And if I log in, by going to this website and just changing this to another avatar's name, it would instantly change my visualization to anybody observing me. So the other avatar that I had ready was of David Reekman from the eMERGE team. And so it wasn't a very good scan, but you could see that instead, I'm sure you've always seen thin people wearing fat people suits. Well, here's a fat person controlling a thin person suit. So it's quite good. And that's it. So I guess. Thank you very much.